Hello students, this is a demo video for the classes of IIT Jam Physics. In this video I'm going to show to you some details about the exam. I'm going to guide you how to prepare for this. I'm going to also walk through the weightage distribution and the proper pattern for the preparation of the exam, and I'm going to solve a question for you which has come in the exams many times actually, and based on this question we are going to see some concepts. Alright, now to start with the exam itself, IIT Jam Physics actually is the one of the easiest exams if you see the other competitive exams for MSc entrance. It is easy for two reasons. First is that the syllabus scope, as you can see here, is much lesser when you compare to other exams of the same level like JEST or TIFR, or sometimes even Delhi University papers. You will see that they are more difficult than IIT Jam paper. Alright, you will need to focus on your degree education very properly. Alright, refer to a lot of standard books, and you don't have to have more than more than extra knowledge to qualify the exam with flying marks. That's not a problem. Alright, you all know that the cutoff for IIT Jam Physics is very less. However, merely qualifying the cutoff will not help you anywhere. For this you have to be very careful about your marks as well, very careful about negative markings, the pattern and all. I'll tell you about it later. So what happens here, the first thing to talk about is the method of preparation here. Okay, so here you can see we normally divide the entire syllabus of your IIT Jam Physics and equivalently your other competitive exam as well, just like your JEST and TIFR. Alright, now when you prepare for IIT Jam, don't forget that you are preparing for all the other exams as well. So keep in mind that your preparation should be overall. Alright, don't ever assume that you will just write IIT Jam and let things be. That's never going to happen. Alright, we are always going to be preparing for other exams as well. That's a very important thing. Don't depend on only one exam. Alright, now as far as the syllabus is considered, we divide the entire syllabus into three parts, alright, based on their ease and their importance. The most important part is this block 1 here. It contains 4 topics: mathematical methods, classical mechanics, electromagnetic theory and quantum mechanics. All these 4 topics are of utmost importance to you. Alright, now even if you're preparing for some higher exams, even if you're preparing for your future endeavors of GATE and CSIR, these will be the foundations. Alright, it's very important for you. Now when you talk about the topics of mathematical methods, in a very rough overview, every university will provide you mathematical methods in physics in your 3-year degree program. Apart from that, you have to have some more than basic, alright, above basic, above average idea of your BSc mathematics level syllabus. It's not something difficult. The questions that come from mathematical methods are really very easy. Alright, only if you have not focused properly on your mathematics classes, you will not be able to solve the problem. Otherwise, when you see the questions and if you know the topic nicely, you will see the question is actually a very basic type. Alright, classical mechanics, electromagnetic theory and quantum mechanics are the founding pillars of the core of physics. You will see that in almost every exam, the weightage of block 1, including mathematical methods, is always maximum. Alright, whichever exam you prepare for, it will always be maximum. This block will be helpful to you for every interview that you write. Alright, any entrance exam for any university or even for any job of research and all that you go across, that you come across, you will come across all that when you do your MSCs and all. So you will see that in this block 1, your preparation should include concepts. Alright, you should be very familiar with the theory, very extremely familiar with the theory. Alright, this theory part is mostly important for your interviews. Alright, the method of being selected in a college depends on how you perform in the interview. The IIT Jam exam is just a qualifying exam, that's all. Alright, it tells that you are qualified to sit in the interview. After this, it depends on your performance in the interview. So just by being able to solve problems is not going to be enough here. Alright, okay, now out of these 4 chapters, you are supposed to be familiar with all of them. Alright, you cannot do selective study here. The second one, however, is much easier. Thermodynamics and statistical physics and electronics and solid state are topics that are more based on formulas. Alright, so questions here will be completely formula based. Very few questions, like if you're preparing for jest, you will find papers in questions of jest and differ to have some concepts coming from these four chapters. Apart from that, every other exam will be completely formula based as far as these four chapters are considered. The other benefit of these four chapters is that even if you're preparing for some higher level competitive exams, most of the questions of these exams can be solved only from the BSc level of these four chapters. Alright, now as a preference, you can select any 3 out of 4 chapters here, alright, which should include, I'm not saying it is it's necessary, but it should include thermodynamics and electronics. Alright, so 3 out of 4 chapters from these this 4 chapters, the block 2 is going to be really very helpful for you. Block 3 is the easiest one. Alright, it's completely theory. Very few ideas of numericals, very few concepts of mathematical problems will come from here. Atomic physics, nuclear physics, and some peripheral topics of that you learn throughout your course of BSc physics. Sometimes questions of homogeneity of equations and stuff like that. It's not something very difficult. Alright, now this topic here is very easy. Alright, this will take a hardly 1 month during your self preparation to finish all these chapters properly. This will take around 2 months, but this itself must take a minimum of 4 months. So you understand the weightage here, you understand how important this is. As you can see right now, you will see that there are many exams that you can apply for when you prepare for IIT JAM. Alright, so it's very important for you to go through the question papers of all these exams and not just depend on IIT JAM physics. Alright, IIT JAM, you can see, will act as the foundation for the preparation of other exams that you will later be attempting in your life, GATE and CSIR exams. Anyways, so now we come to a topic that is one question of quantum mechanics, that is a previous year paper of the previous year question of IIT JAM. The wave function of a quantum mechanical particle is described as the following. Alright, 3 by 5 phi 1x, 4 by 5 phi 2x, with phi I phi j described as a Kronecker delta symbol. We'll come to this later. The energy eigenvalues of phi 1 and phi 2 are minus 1 electron volt and minus 2 electron volt respectively. The energy of the particle in state psi is equal to how much? And you have 4 options given here. Now, when you talk about the energy of the particle, what is being asked is the expectation value of the Hamiltonian operator. Alright, now whenever you have an operator d cap, the expectation value of d cap is a very easy one to find. Here it's psi d psi divided by psi psi. Here I've used Dirac notation, Ket and Brown notation of given by Dirac, which in Schrodinger's notation basically means psi comma d psi. This is d cap psi divided by psi comma psi. This here is known as an inner product. Alright, this bracket here, if let's say I describe psi comma phi as an inner product, this would just mean the first state you take as a conjugate, the second state take it as it is, and then integrate it over the volume of space, that is dx dy dz. Alright, between the limits in which the state has been described. This is known as an inner product. Now the reason an inner product is there in the denominator as well is to make sure that the wave function is normalized. For this reason, we have this definition given in the question. Now, if you describe psi comma phi as a Kronecker delta symbol delta ij, what this means that if psi is equal to phi, the value of psi comma phi is 1, meaning they are orthonormalized. normalized. Now what does this mean? It means that if you measure the probability of a particle prepared in the state phi and tested in state psi. Now this is something very important. When you talk about psi comma phi, it means the particle is prepared in state phi, but it is being tested in state psi. Alright, and this probability is equal to 1 if psi and phi are orthonormal to each other. Alright. On the other hand, if psi is not equal to phi, then psi comma phi is 0. This is known as orthogonality. Orthogonality. A very important understanding of orthogonality is that if psi and phi is equal to 0, the inner product of psi with phi is 0, it means that the two states are independent of each other. Independent means what? The two states cannot be shared by the same particle. If the particle is found in psi, it will never be found in phi. Likely if the particle is found in phi, it will never be found in psi. That's the idea. Now to solve the problem, we use a trick here. I have shown you the equation for the expectation value to find the expectation value of a given dynamical variable. In this case it's energy, but then there is another way. A very simple trick can be used here. If let's say the wave function or the state function psi is expanded in orthogonal basis, alright, you can see here it's 3 by 5 phi 1 plus 4 by 5 phi 2, and phi 1 phi 2 are orthogonal to each other. Then if you use any operator on psi which gives you the eigenvalues as d1 for phi 1 and d2 for phi 2, the expectation value of d can be given as d1 times a1 square plus d2 times a2 square, where a1 and a2 are the probability amplitudes. Now what is a probability amplitude? It's the square root of the probability of finding the particle in the given state. So the probability of finding the particle in the given state phi 1 will be square of 3 by 5, becomes equal to what? 9 by 25. Why? Because a1 is the square root of probability. You can call it the square root of probability of finding the particle in state 1, like that. Got it? So in this concept you will realize the question becomes really very easy. Now the eigenvalue of the two wave functions are given before. Eigenvalues are minus 1 electron volt and minus 2 electron volt. So while solving, you will see that the expectation value of energy here, according to what we have just discussed here, should be equal to minus 1 electron volt times 3 by 5, as you can see here, 3 by 5 the whole square, plus minus 2 electron volt into 4 by 5 the whole square. Now all you have to do is solve it. This becomes minus 1 into 3 by 5 the whole square is 9 by 25, minus 2 16 by 25. Solve it, you get minus 9 by 25 minus 32 by 25, and you get the idea as minus 41 by 25 electron volt. And if you see, option number A is correct. Got it? This is how a simple question of quantum mechanics can be solved.